Hello, guys. My name is Raj Sharma, and today we'll be covering a topic in data science, a very important topic in data science that is linear regression. So, what is this linear regression, and what is this AI and everything that we hear nowadays in politics and in our daily life words? We see the things, we say the things like AI has taken over many jobs, and we listen a lot of things about the buzz term that it is AI, it is something AI. So we just came across various fake things and everything. So we'll be discussing about those two, and we'll be just covering our topic linear regression, and we'll talk about the AI things. So what things we'll be covering in linear regression? Basically, in linear regression, we'll be covering its theory, its mathematical statistics, and its practical implementation in my Python notebook. And let's just start. So, what is this artificial intelligence? So, artificial intelligence introduces machines and enables machine to think about some new data and generate something new. Basically, it allows machines to think in a new manner, think in a humanly way. It enables machine through various statistics and tools. It utilizes various mathematical tools, for just like probability and linear algebra, and actually enables machine to think just like we do. For example, there's something that we see a lot, like there's a thing known as ChatGPT, which generates the new data every time. If you ask the same thing again and again from ChatGPT or various models, just like Gemini, it won't give you a particular example because in the background, the models are trained to intelligently think about it. So let's just come to it. So artificial intelligence covers the whole AI things. The artificial intelligence is this AI which has a further part known as machine learning. So artificial intelligence is the whole thing in which we have in which we utilize statistics and tools, that is machine learning, and further advancement to the machine learning covers the deep learning, where we study about various neural networks and various architectures, just like transformers are used in ChatGPT, in BERT, or various generative models to generate images, to generate fake audios and everything. Deep learning is used in them. And there's a further thing that is data science. So data science is the thing that utilizes, that covers most of, basically it's just an intersection between all of these things. Data science further has its own parts. Data science is basically a science of data in which we study the data. We make stories out of data that need not to be very much practical, but it utilizes various tools and many things that are different from AI, but it majorly revolves around the data. Let's come down to our main topic, that is linear regression for today. So, what is this linear regression? So, we have this machine learning. In machine learning, we further have two parts. One part is the one in which the data is properly given to us, the market data. I This thing might not make a clear picture to your mind right now, but as soon as we go through, it might get to you. So basically, what is this linear regression? Linear regression is a fundamental statistical and machine learning method used to model relationship between dependent variable and independent variable. Linear regression, statistics, it's a method to model the relationship between dependent and independent variable. So basically, we will have a table. In that table, suppose we have a table of 10 people, of 10 rows, in which we have asked 10 people to give their heights and weights. And height of 10 people is known to us, but the weight of only 9 people is known to us. Do you know, machine learning will enable us, data science, machine learning, and this AI thing will enable us to predict the weight of the 10th person in a good probabilistic way, that will be a kind of the most relevant answer according to the statistics. So let's see what I was telling. For example, we'll ask for the weights and heights from various people. So we have this data from five people. So I'm giving you the basically I'm giving you the entire picture that will be done. Let me come to this first. So basically we will collect the entire data from 10 people as we have collected. Then we will plot the data. What do you mean by plotting the data? Plotting the data is just like these are the values. Suppose this is the height, this is the weight, and this is the height. These are the various points that we have plotted in the x and y axis. Okay, so this is collecting the data and plotting the data. Then fitting a line. Fitting a line is basically considered to draw a line that suits the data the most. And what do I mean when I say it suits the data the most? Basically, our target is to draw a line in such a way that it has the minimum error in this. We'll come to the error part later, but the main idea is we'll collect the data, we will plot the data, then we will fit the line as close as possible to the data points, and then we will predict the value. So we have collected those 10 people's data, then we'll be able to predict the final height of the 10th person. So what is a dependent variable? What is independent variable that we talked about? So the target variable, that the thing that we are going to predict is known as the dependent variable, and the thing that we know about the person, those things are known as the independent variables. So let's go to the next topic, the types of linear regression. So basically there are two types of linear regression. One is simple linear regression and the another one is multilinear regression. What are these two? In case when we have one independent variable and one variable that is a target, that will always be there, one independent variable, then we'll call it simple linear regression. And when we will have more linear, multiple independent variables, that will be multilinear regression. It might not have come to your mind. Let me explain it in a better way. For example, when I talked about 10 people, I considered their height and weights. Now, think of a practical world. Think in a practical way, just like it's not always true that if I'll have the weight, then I'll be perfectly able to predict the height of that person because there are various other factors that might affect the weight of that person, just like the age, just like the gender, just like if the person plays the game or not, any sports or not. So there are various factors that will be considered. And if we will consider various factors, just if we'll consider various variables to predict any particular target, then we'll call it multilinear regression. And if we'll just have one independent variable and we'll have one target variable, that will be known as our simple linear regression. So it might be clear to you. Just next move on to the mathematical, the things that I was telling you, the mathematical things. So the simple linear regression has this equation. Oh, I'm sorry. And this multilinear regression has this equation. What are these equations? This is the equation of a line, the thing that you are seeing here. This is your independent variable, and this is the thing that is our target. For example, if we are to predict the height of any person, then y variable will be our height. The things that are known to us, that will be our x variable. And in case of multilinear regression, consider this to be our height, as I said. Oh, I'm sorry. Consider this to be weight. I don't know, I'm telling them interchangeably. Let's fix them. This is our height. The height we are going to predict of that person. Weight is known to us. We'll predict the height. Weight is known to us. Age is known to us. Suppose gender is known to us. And various other things are known to us. Then we will predict the height. So this is the main idea behind the simple linear regression, multilinear regression. I think this is more than clear. So, as I told you, we'll just collect the data, plot the data. We'll draw a line. We'll try to fit the line to the points as much close and as much good, I'll say, as possible. And how we'll do that? We'll do that with the various things. Basically, our main target is to minimize the error. What is the error? Error is the difference between the predicted value and the original value. What do I mean when I say this? Suppose these are those people data. We have, this is our weight, this is our height, the height that we are gonna predict. This is simple linear regression, and these are various values that I have plotted here. Okay, and as I told you, the third step, we'll try to fit a line. So next time, whenever I'll ask you, first person's weight is given to me, the height you will tell me won't be this, nothing, like not the actual height. It will be this line. It will be the value that corresponds to the x-axis on the y-axis, corresponds to the y-axis of this line. I think this is clear to you. So our main target is to minimize this gap that you're seeing here of all of the one. And what it will do, it will just give us the most best possible answer that is possible. And the terminology that is given to it is mean square error, MSE. There are other things too that can be used to minimize the error in this, but we'll be covering the MSE in this one case. So what is mean squared error? So it is nothing. It is the mean of the difference of the square. So basically we'll have the actual values. We'll have the actual values. We'll get the difference between these values, this, this value, this value, this value, this value, this value. We'll have their differences. We'll have the square of those differences. Basically, we'll have the square of these things, and then we will find out their mean. And our main target will be to minimize this square error. I think that this is more than clear to you. And our main target is to lower the MSC. The better, the less the MSC is, and the more the perfect the model is. I think this is more than clear. So let's go into more technical way how the model and the machines do this. As we say, there are very various algorithms that are utilized by the model to actually do these things, how the model is going to do this. In a very simple way or terms, I call it MSC, that I just told you there are various means that can enable us to minimize the error. And the most famous way is gradient descent. So we can have a whole video on the gradient descent, but for today, let's just understand gradient descent in a simpler way. So as I told you, our target is to minimize the mean square error as much as possible. Our main target is to minimize the error. And how are we going to do this? So gradient descent is that way that we are going to do. So I'll tell you, there are gradients, if you know what gradients are. So there are various gradients, there are various differential equations, there are various derivations that are derived to its minimization, and the minimization is done of the function of the error, and that's how we do it to the level till which the mean is just minimized. I mean, the MSC is just minimized. So it is just like calculate the MSC, find its gradient, and what does it mean, direction of steepest descent? Consider a mountain. In a mountain, if you are at the top, you have different ways to go down. But what's the fastest way to go down? That is going through the steepest, not going through the way that is like this, but that is the steepest, the most, that has the most angle with the normal. With the normal is this, which have the highest angle with the horizontal level, the steepest. Then adjust the parameters, repeat, start randomly. Basically, it again and again follows a cycle of repeatedly minimizing the error through the gradients, and that's how it does it. So, what are the applications of linear regression? So, linear regression is a good model, a very important model, but it's not utilized as much as the other models that we have today. We have logistic regression, we have XGBoost, we have decision tree, we have random forest, we have various other models which are far better than the linear regression. But linear regression also stands out because the data matters the most, not the model that you're using. So it's better to use it basically depends on various factors. So what are the applications of linear regression? So the linear regression can, as I told you, the example I told you, when we had to predict the height of the person, when we were given the weight, and just like that, for example, if we are to predict the prices of any housing, just like for example, if I want to purchase a house in California, and if I were to think, then I'll just have some factors in my mind, just like the cost that I'm gonna spend, that I'm telling the independent features, the cost I'm gonna spend there, and the square feet of the house of the area that I want to have, the area in which I'm purchasing the house, and various other agents price that I'm willing to pay, and another factors. In that one case, we can use the predicting house price we can use the linear regression for estimation of the salary for students predict for prediction of the marks and for prediction of the sales forecasting. So one thing is very common in all of these four things. That is, the data is continuous. That is known as the continuous data. And there are two kind of data that we might come across. That is the classified data, and one is the linear regression based data. In all of these, we have the numerical terms. In a broader way, I'm saying this because we can have numerical values in classification model too. See, here we are dealing with prices. Here is the salary. Here's the marks. Here's the sale. So there is no discrete value. There's always a continuous value that is used. So whenever a data comes to your mind in which you have to predict something that has much relation to do with the continuous range of data with no discrete values. And what do I mean by the discrete values? Discrete values are the values which have the strong, just like strong values, discrete values, not a continuous values. Just like if I'll say, uh, I'm gonna play cricket or not, considering various factors. So, for example, if I were to play cricket, then I'll be considering the sunny, if the day is sunny or not, if the day is Sunday or not, if there's raining outside or not, if it's raining outside or not. So, in those factors, you can see that there's no possibility of numerical values in that. But in housing prices, there's a continuous value. There are continuous values that are possible. So let's keep the theory parts till this because I think it's more than enough that I have covered everything that's possible in linear regression. Let's come to the notebook and have a So, welcome again. I think the last things that we discussed were very clear to you. The topics that we covered in the linear regression, be it the theory, be it the some good things about the AI or the gradient descent or the mean square error and the mathematics behind the scene. So, let's see this notebook. This is basically my Python notebook. This is the thing that I did some months, years back. So, this is the housing price prediction using the linear regression model. So we have this USA housing.csv file, separated file, in which I were to implement the linear regression and test my model in this. Let's just quickly cover the things. This is the description of the mathematics of the statistics in this, and this is basically done to study the data. These are the columns in the data. These are basically the features that are there in the data, like the number of rooms, the income, the population, the price, the address. So basically, we have then performed the EDA, the exploratory data analysis on this to study the data in a more deeper way. We have utilized a Seaborn here, and we have plotted various graphs against the important features. Then we have done the disk plot. Then we have considered this heat map for seeing the correlation between the features. Let's quickly come to the main thing, training of the linear regression model. Basically, this is the dependent feature, and these are our independent features, and we are to predict the values of the prices when these things are given to us. So simply what we do, we simply call a model from sklearn, and we will firstly split our data into xtrain, xtest, ytrain, ytest. So what this is, basically we divide the entire data in two parts. That is, one is training and one is testing. And in that too, we have the xtrain and we have the y test. We have the xtrain, we have the ytrain, then we have the xtest, and we have the ytest. And the split is zero point 0.4. That means 40% of the data is reserved for the testing purpose. So then, oh, I'm sorry. Basically, this is for splitting the data. This thing is called from the sklearn for splitting the data. Then we have imported our linear regression model into our LM. Then we have tried to fit our trained data, the 60% of our data to the LM, to the linear regression. And then we have this is the basically intercept. If you remember when we saw y equals mx plus c, then in that the slope was m and the c, the point at which the line intercepts the y axis, is the is this value. And let's move further. Now this is the main thing. So when we utilized the linear regression model, we tried to actually see the plot against the predictions and the tested values. Y test is basically the values. These are basic, you can consider them to be the actual values, and these are the predictions. So as you can see, both of the axes have the similar values, just the exact values, because one of them is the y test and one of them is the prediction. And as you can see, we don't have much variation in them because most of the values are very close to each other because we don't have much differences because it's a well-trained data. And let's see further. Uh, In the above scatter plot, we see the data is in line shape, which means our model has done a good job. That's what I said, because we performed it in a very good way. We didn't perform much of the feature engineering in this one case, but yes, it has good performance. Then in the last, we have these matrices. As I told you, if you remember, there are various error metrics that we utilize, and in this particular PPT, we discussed about the MSC. So we also have other things just like RMSC, MAE, and MSC. So all of them also tell us about the performance of the model in a statistical way. You might see that these values are way too much, but this is because the prices have a good numerical value. It doesn't mean that the model is performing very bad. It just means that the data that you are utilizing has very extreme values to the large numbers. So I think the linear regression is clear to you. And in this one example, we have used the housing prices prediction, but we can also implement linear regression on different things in which we have the continuous data. And thank you. So thank you guys for considering my application. I might have fumbled a lot throughout the video, but the main thing is I didn't write any script or anything that I'll be covering. I just listed out the points that I'll be covering, but I didn't cram anything. I just wanted it to be very real, very raw, because I just wanted to draw out the best possible explanation from myself. As I explained to my engineering friends, I do the same thing. So this is not very often that I record in front of camera, and I would love to hear back from you. And thank you. Have a nice day.